Hello friends, welcome back. In the previous tutorial, we tried to simulate this scenario. We identified three different classes: TV class, AC class and refrigerator class. But we know that TV, AC, refrigerator are actually devices. So we created a class called as device, which is going to be a generic class, and we identified that every device can be switched on. So there is a behavior switch on which is common to all the devices. So we kept that in this class called device class. Then what we did, we have written debug.log device switched on, so that whenever we switch on the device, it should show us that that device got switched on. Then later what we have done, we know that TV is a device, AC is a device, refrigerator is a device. So we inherited TV from device, AC from device and refrigerator from device. And what we have done, we have hidden the inherited method in every class so that we make the switch on method more specific. When we call the switch on method on TV, it should show us TV switched on. When we switch on the AC, it should tell us AC switched on. When we switch on the refrigerator, it should show refrigerator switched on instead of showing device switched on. So we have overwritten, you can say. Then what we have done is, we wanted to create a remote controller, universal remote controller that can be able to switch on the TV, switch on the AC, can be able to switch on the refrigerator. To do that, what we have done, we created first a TV, then we created an AC, then we created a refrigerator. Then we created a remote controller class that is also going to have a method known as switch on. Now this remote controller switch on method can be able to take a TV. We have kept a reference to TV, like TV we have created. And when we say remote controller switch on TV, then what it does, it calls inside of the body TV dot switch on. As TV reference variable is of type TV, so when we say TV switch on, it calls the TV class member switch on method that displays us TV switched on. To switch on the AC, we needed to create another method with the same name as a switch on. That means we need to overload the switch on method with a reference variable of type AC instead of a TV. So we created another method which is going to take an AC. And when we say AC switch on, it displays AC switch on. Similarly, for refrigerator also we created the same method. And we have seen that this works perfectly. It displays when we run the code, we know that we are going to get TV switch on, AC switch on, refrigerator switch on. I shown that in the previous tutorial. I just save it and come back and run the code. If I run the code in the Unity, you are going to see that TV switched on, AC switched on, refrigerator switched on. And we understood there clearly. Then we got a problem of redundancy. Then because of this method, we got the problem of redundancy. If I have 100 devices, then I needed to write 100 different methods. That was a problem. That's really a problem. Then we thought, is it possible for us to create a single method that can be able to take any device? We know that every device is of type device. TV is a device, AC is a device, refrigerator is a device, and also we know that if I create microwave oven, that is also gonna be a device. So why can't we create one simple method which takes a device and calls respective device when we pass a respective reference variable? Here we created a method which is going to be a base class device reference. It is going to have a base class device reference, like device. This reference variable is of base class type, that is a device class. Then when we say rc dot switch on TV, it takes that. When we say rc dot switch on AC, it takes that, no problem. rc dot switch on refrigerator, it takes the refrigerator. Why? Because base class reference variable can point to any of the derived class instances. We know that TV is an instance of the derived class TV. AC is an instance of an AC class which is derived from the device class. So all these are derived class instances. To them, the device class reference can point. No problem in that. We know that implicitly, automatically it will get converted to that specific type. But as we know that when we call this, what happens, we understood in the previous tutorial that as device reference variable is of base class type. When we say device.switchOn, it always calls the base class methods. So it always calls device switched on. Even though I say RC switch on TV, it displays device switch on. Even though if I say RC switch on AC, device switched on only it will display. If I say RC switch on remote controller, switched on refrigerator, what it does? It calls device switched on only. Only one reason is the device is of base class type, so it can be able to access only base class members. So here always it displays the device switched on. If I save and come back and run and show you, we are going to get device switched on, device switched on, device switched on. Now we expected here that TV switched on, AC switched on, refrigerator switched on, but we are getting unexpected result. To solve this problem, as I told, we are going to understand function overriding, that is dynamic polymorphism. There the base class reference can be able to call the derived class methods instead of calling the base class method always. So to do that, what I do means I write everything from scratch so that you people should not have any problem. I just delete every code from here. We start from the device class. Let's begin. I create a class called as device. This is going to be a base class for all our devices that we are going to create. And as we know that we are going to have a method public void switch on, switch, switch on. And what is its responsibility? Its responsibility is to display device switched on, switched, switched on, bracket close, semicolon. I can save this. If I create this device reference, device, device is equal to new device, it might be any device. And if I say device dot switch on, then what it does, it calls as device is of type device class, so it can call the device class method switch on. If I save and run, we get device switched on. I come back to Unity and run the code. You can see that device switched on got displayed. Let's proceed further. I create a class for TV and we know that it inherits from the device class, opening brace, closing brace. As we have seen in the previous tutorial, we are going to override the meaning of this class method switch on, switch, switch on, bracket, opening brace, closing brace. We make it more specific by saying debug.log TV switched on, switched on, bracket close, semicolon. I do save this one. Now what I do, instead of creating the base class, I am going to switch on the TV. TV is equal to new TV, bracket, semicolon, TV dot switch on, bracket, semicolon. Now what it does, we know that as we have given a new meaning to the switch on, it calls the TV switched on. I save it, come back and run the code. We get TV switched on. Good. Then I create another class called as AC, which is going to be inheriting from the device class, and it takes a public new void switch on, switch on method. We are giving a new meaning to this switch on method in the AC class. That is going to be debug.log. I can say here AC switch on, bracket close, semicolon. I can save now and I can create AC also. AC is equal to new AC, bracket close, semicolon. I need to create AC dot switch on, bracket, semicolon. Save this. Now we get perfectly TV switched on, AC switched on. Let's save, come back to Unity and run and check. We do get TV switched on, AC switched on. Clear this. I have tried here ED, save it. But we know that we are interested to create a class called remote controller, which is actually responsible for switching on void switch on a device, D-E-V-I-C-E, device, device, D-E-V-I-C-E, device, opening brace, closing brace. So we want to give a specific device, it should be able to switch on that device. Device dot switch on, bracket, bracket, semicolon. That is the responsibility of the remote controller. So here, if we create a TV, we created a TV, we created AC also. But if I say now remote controller RC is equal to new remote controller, bracket, bracket, semicolon, remote controller switch on TV, save. If I save and run, as we know that TV is a derived class reference, we are sending that to the base class reference device. As it is a base class reference, it is pointing to the derived class instance TV. Its type is of TV, but as originally it is of type base class device, so it can call the base class method or device class method switch on. We are going to get the output device switched on. Let's save it, come back and run and check. We are going to get device switched on. Let's do same thing for AC also. If I say remote controller switch on AC, it is going to say device switched on. Why? Because AC is a derived class reference address of the derived class instance AC. So if we send that, the device starts pointing to that AC, but as it is originally of device type or the base class type, it is going to call the base class method switch on only. Let's save and come back. It says device switched on for us, device switched on, device switched on. But as we are expecting that using this base class reference, I can be able to say here TV switched on, AC switched on. To solve this problem, we are going to use two important keywords. Those are known as virtual and override. Virtual methods. Here we are going to understand virtual methods, overriding virtual methods, how they are helpful to get the desired result. Any class, you can see this class is a device class. Here we created a method called as switch on. Here we don't have any idea that which device we are switching on, right? Correct or not? So what I do to this method, I am going to use a keyword called as virtual. Let's read this. What is virtual keyword? The virtual keyword is used to modify a method or a property. You can use this with the method or the property. You can use this keyword with methods as well as properties. Declaration, in which case the method or the property is called a virtual member. It is going to be treated as now a virtual member or a virtual member method. This one is a virtual member method. I am not going to hide this method in the derived class. What I am going to do means I am actually going to override. Now what is override? The override modifier is used to override a method or a property or an indexer or an event. You can override. So if here we are overriding. Similarly, this virtual method called switch on is also inherited to the AC class, right? Because the AC class is inheriting from the device. Instead of hiding, I am going to say here also override. I just save this file. Here we are overriding a virtual method. If I run the code, this time what happens, we are going to understand step by step. First thing, let me remove this AC class also. We make it more simpler. So we have only three different classes. First one is a device class, which is a base class for the TV class, and device class has a virtual method, and we have overridden this in the derived class TV class, and we have a remote controller class which takes a base class reference. So I can create first a TV. TV is equal to new TV. I have created a new TV, and I also create a remote controller. Remote controller RC is equal to new remote controller, and I say remote controller switch on TV, bracket close, semicolon. Here we created a derived class instance, that is the TV we have created, and we are sending that reference to the device class and device reference, and this device reference variable is a base class reference variable, so it should call the base class method. But instead of calling the base class method, it calls TV switched on. Let's see that one. If I save, it displays TV switched on now. If I run the code, you can see that we got TV switched on. We didn't get device switched on. Why? That is the speciality of virtual override. Let me copy this code and paste it in Paint so that I can be able to explain you guys how it is working. Here we have the code. Try to understand this, guys. When we say start method, of course the TV is going to be created on the heap. Let's take this one is a TV instance on the heap and its address is, let's take #1. Remember that if you do not have any data members, at least 1 byte of memory will be allocated on the heap for that instance, any instance that you create. Because there are some reasons are there behind the scenes, some other data is also going to be present even though you do not have any data member. Then of course left hand side on the stack we will be having one memory location for a TV variable. It is going to have #1 inside it. It points to that memory location. Now when you create a remote controller, of course remote controller is also going to be created. #2 let's take, and RC is the name of the remote controller here, RC, and it is going to have #2 inside it and it starts pointing to that memory block, no problem. When you say RC switch on TV, RC switch on TV, we are sending the TV here. You should always remember the rules. You should not forget the rules. There will be always one extra parameter, remote controller, this is present here. Here we will be passing RC as a one extra argument. We should not forget those rules. Here those rules are not necessary. That is the reason I am just explaining you in a simple way. When I call, it goes to the switch on method of the remote controller, right? And here we have one variable device. So we are going to have a device variable. This is a device variable. Let's take, I write D only, and we are sending TV to it. So TV is having #1 inside it, #1. It starts pointing to that memory location. Once it starts pointing to that memory location, the device reference variable is now of type TV. Implicitly it got transformed to TV type, but originally it is of device type. That you should remember. Originally it is of base type. So it can be able to access only its members. So what happens here when you say device switch on, it goes to the base class method only. It goes to call the base class method switch on. But it finds that this switch on method is marked as a virtual method. By seeing that keyword, it understands that I should not execute this code. It understands, device reference variable understands that means maybe in its derived classes, this switch on method overridden. If it is overridden in the derived class, that derived class method I have to execute. So control, without executing this, it checks the TV class. There it finds that there is a method called switch on which has the same name and same syntax, and it has a keyword override. By seeing that, it understands that okay, the switch on method is overridden. Now what system does, it executes this body. TV switched on will get displayed on the screen. Then the control comes back. After executing all the members in this body, the control just comes back. This is how it works, guys. Understanding? This is an important part to understand because virtual methods, overriding virtual methods is one of the most important concept of inheritance, which helps you to create more manageable and extendable codes. So hope you guys have understood what I have explained, how the code is working, how the control moves from one phase to another. Now let's create AC also. I create another class. Now it is more flexible. You can see if I say class AC colon device, I can create another device called AC. I can create a override. You can see that I am overriding this virtual method because we know that this public virtual method will get inherit to the AC class. So here we are overriding void switch switch on, and I write here debug.log AC switch ed switched on bracket close semicolon. This time I am going to say I am going to create AC also. AC is equal to new AC bracket semicolon, and then I say remote controller switch on AC bracket close semicolon. If I save and run, you are going to get here AC switched on. You are not going to get device switched on. Let's see that. If I run the code, you can see that we got AC switched on. Right friends? This is how it works. you can create another class called refrigerator. It inherits from the device class and it also overrides the inherited switch on method. Here I say refrigerator switched on, and I can create a refrigerator RG is equal to new refrigerator, and I can say here RC remote controller switch on the refrigerator RG. I save this one, come back to Unity and run the code. You should see TV switched on, AC switched on, refrigerator switched on. You can see that TV switched on, AC switched on, refrigerator switched on. That is the speciality of virtual method. You can now make it much more flexible. You can see that you can add one more device if you want. You can say class microwave oven. It is also a device, and I can say here I have to override this virtual method. If you want, you can override. If you do not override, then what happens means it will execute this one only. Let me show that first. Then I can create here microwave oven. I say MO is equal to new microwave oven bracket semicolon. Now here if I say remote controller switch on microwave oven, if I say, we know that when I say RC switch on MO microwave oven reference will get stored in the device. We know that device is of type base class, so it first goes to the base class switch on method. It goes to the base class switch on method, that is the device class for the microwave oven. Device is the base class. It goes there and it finds that switch on method is a virtual method. If it is a virtual method, then it checks that whether its derived class, that is the microwave oven, overriding the switch on method? No. As it is not overriding, it executes this body. So it displays device switched on. We can see that one. If I come back and run the code, you will see the last output as a device switched on instead of microwave switched on. You can see the device switched on. Remember that what happens means when you inherit the base class, the virtual method will get inherit to the derived class as a virtual itself. So it will be virtual only in the derived class. And also you should remember that if you have a virtual method, if you want to give a body a new meaning to it, you can give it. Understanding? Now I can give here new meaning to switch on, and I say here microwave oven switched on. This time if I save and run, we know that it is going to display microwave oven on the screen. If I come back and run the code, you can see that we got microwave oven switched on. So remote controller has an interface which is more flexible now. You can use this for any device. You can switch on any device. Now it is a universal remote controller which can be able to switch on any device. And you can see that we have only one method which is performing all the operation. We have reduced lot of redundancy. Understanding? Otherwise, if I do not have the facility of virtual and override, then I have to write switch on method here 4 times. Right friends? We reduced this part. I hope you guys have understood what is virtual, what is override keyword, how they are useful to get the desired result, make our code much more flexible, create a single interface, and also you can see that the device at runtime controller is going to check which type of device you want to switch on and run. This is happening at runtime. This is not at compile time. Compile time, this remote controller don't know which device it has to switch on. When you run the code, you are telling switch on the TV, then it will switch on the TV. AC will get switch on, remote refrigerator will get switch on, microwave oven will get switch on at runtime. That is the reason it is known as dynamic polymorphism. Understanding guys? So for this tutorial, this much is enough guys. Try to understand, watch this video again and again. In the next tutorial, we get little bit more information. So thank you guys. Thank you very much. See you in the next tutorial. Keep learning, keep coding, keep sharing.